Comparing functions, lesson 13 notes. Example number 1. Before we approach example number 1, let's talk about the slope-intercept form. We've talked about slope-intercept form. It's nothing new. Slope-intercept form is y equals mx plus b. So you'll often hear me say, solve for y. Solve the equation for y. The reason why we want you to solve for y is because we want the equation in slope-intercept form. If it is in slope-intercept form, then the m, the number in front of x, is your slope, which is the same as rate of change and unit rate. So slope is in front of x, and your y-intercept is behind x. Remember, the y-intercept is where it crosses the y-axis. So your slope or your rate of change or unit rate, that'll be the number in front of x, and your y-intercept is behind x. So m is slope and b is y-intercept. Example number 1. It says the table and the equation below both represent linear functions. Which function has a greater rate of change? Underline the word greater. And then underline the word rate of change. Actually, let's put a double underline under greater. Okay, so we are going to find the rate of change. And again, the rate of change is the slope. Let's start with function b. You're given an equation. So when you are given an equation, you must solve the equations for y first. Must solve equations for y first. Pause your video and get this written down. All right, well, we lucked out because this equation is already solved for y. I don't have to do any work for function b. I know that my rate of change, which is my slope, is in front of x. So my rate of change, which is my slope, is the number in front of x, which is -3. So that one was nice, no work involved. However, for function a, I need to find the slope or the rate of change. Now, slope is y2 minus y1 over x2 minus x1. In other words, it is the difference in y values over the difference in x values. There's two ways we could do this. We could, pick like an x1, y1, x2, y2, and use your formula 5 minus 9 over 10 minus 8. You could do it that way. There is nothing wrong with that. Or you could simply, and we've done this before, you could simply look at the graphs and know that you're going to subtract 10 minus 8 is 2. 5 minus 9 is -4. So, again, you could do it this way. That's perfectly fine. Or you could simply do the subtraction. And then your rate of change would be the difference in y values over the difference in x values. And -4 divided by 2 is -2. If you put this in your calculator, you would get -4 over 2. You would get the same thing. So it is up to you how you would like to find the slope. As a matter of fact, let's go ahead and write that down. So we'll do or slope equals y2 minus y1 over x2 minus x1. -4 over 2 is -2. I don't care which way you do it. It is up to you. Okay. Now, we have to compare the two. We have to compare the two. So, for function a, my rate of change is -2. For function b, my rate of change is -3. Now you need to be careful. Which number is greater? Well, when you are talking about negative numbers, it's kind of backwards. Remember, when you're talking about negative numbers, it's the number that is closest to 0. So in this case, the -2 would be greater, and my final answer would be function A has the greater rate of change. Function A has the greater rate of change. Okay. Pause your video and make sure you have absolutely everything written down. You need to have this written down, you need to have this written down, all of this written down, and so forth. Please make sure you have it all written down in your notes. If you have any questions on example 1, please let me know.